Another problem that we can work that requires radian measure is something like this. Suppose we have a winch. This is a circular winch that is spinning on its axis, and it pulls up this rope or this chain with a weight attached to it. So as this spins, the weight is lifted. It's a standard, kind of thing you'd see on any sort of a power tool kind of thing. And so as this rotates, this is lifted. The question is, what happens if this goes, say, 1/2 of a revolution? How far is the weight lifted? Well, notice that if this goes, suppose this does go 1/2 of a rotation, 1/2 of a complete rotation. That's 180 degrees. So that means this point at the start is here. 180 degrees later, this point is over here. Right? 180 degrees. So how much rope has been pulled? Well, the rope that was here has been now wrapped around half the circumference of the circle. That is to say, that arc length is equal to the distance this has been lifted. And so whenever we're talking about using a winch like this to lift a weight, we're going to again use S equals R theta. The radius must be given. Theta must be measured in radians. But we can use S equals R theta to do computations like this. So once you understand how one of them is done, or you see how one of them is done, the rest of them fall just very readily into line. All right, so let's see. So how much chain is pulled onto the winch if the winch rotates, and the number I have here is 113.12 degrees, and we're given the radius of the winch is, what number did I say? 1.5. The units don't matter. They all have to be the same unit. This could be in feet, centimeters, whatever. It doesn't matter what they are. All right, so the question is, how much chain is pulled up if it rotates this angle and given that radius? So it's the same problem as before. Again, you don't necessarily need this, but I'll sketch a little picture here of what we have going on. So here's my little winch over here. And here's the weight down here at the bottom. And this is rotating through 113.12 degrees. So the question is, what is the arc length if this is alpha equals 113.12 degrees? All right. Well, once again, we're going to eventually use S is equal to R theta, but as always, we need to convert these degrees. Problems are almost always, very often the most natural way to state them is in terms of degrees. So anytime this is given as degrees. Now, if this is given as radians, you're off to the races. Compute, you're done. But typically these are given in degrees. And so step one is to convert from radians to degrees. And so I have 180 is equal to 113.12. 180 is to that as pi is to theta. So 180 theta is equal to 113.12 pi. Theta is 113.12 pi. Divide by the 180. This is standard, just basic garden variety algebra. Solve for theta. And now, only now, after you show me this, that way I can follow your logic, after you show me this, only now do you go to the calculator. And the value we get here, I've worked this out, is 1.9743, yada, yada, yada. That's the number of value for theta in radians. And so now we're over here. So we have S is equal to R. Now the R value given is 1.5. And theta we just found, 1.9743. Leave the entire decimal string in your calculator times 15. and I think the value I got, and we want to round to, what did I use? I use 2 decimals. Round to 2 decimal places, and I think this works out to be, if I work this correctly, 2.96. So you can check my arithmetic, but I think that's accurate. It's straightforward. It's it really is. It's very similar to the problem with the latitude. Convert from degrees to radians, plug into the S equals R theta formula, and you're out. All right. Now, another way the same problem can get asked. Is rather than give the degrees, the amount of turning is given in revolutions. All right? So let's suppose same winch, same setting, same radius. Radius is still, what was it, 1.5? Except now, we're not going to rotate through a degree measure. Right. Now, again, we want the same 2 decimal places. So R is still 1.5. But now we're going to rotate 2.5 revolutions. Or let's do 2.5 revolutions. 2.5 revolutions. Now we need to convert 2.5 revolutions into pi. We don't use 2.5. This isn't radians. So the question is this. If I go 2.5 revolutions, how many radians is that? Well, this is pretty straightforward. There are a couple ways to, well, one way we could just, simplest way is this. 1 revolution is 2 pi. 2 revolutions is 4 pi. Another half revolution is 5 pi. That will do it. Or we could do the same thing. We could set up a similar, or same thing as we did before, we can set up a similar type of proportion. We know, rather than convert between radians and degrees, or degrees and radians, we can convert between revolutions and radians. We know 1 revolution corresponds to 2 pi radians. 1 revolution is 2 pi radians. 2.5 revolutions is to don't know radians. 1 is to 2.5 revolutions as 2 pi is to theta. Again, 1 revolution is 2 pi. 2.5 revolutions is, that's what we're going to find out. 1 is to 2 pi as 2.5 is to don't know yet. So 1 revolution is 2 pi, 2.5 revolutions is, we're going to find that out. And so now you cross multiply. Well, in this case, 1 times theta is simply theta. And then we have 2.5 times 2 pi. And there's the same 5 pi we had a while ago. So by hook or by crook, the angle theta is given as 5 pi. Now, once we have theta, everything else is the same as before. S is equal to R theta. Theta is in radians. R is given to be 1.5 times 5 pi. And we want 2 decimal places, and I believe this works out to be, if I work this correctly, 23.56. And I didn't give units, so we can ignore the units. So in any event, no matter what you're given, convert to radian measure, and S equals R theta will get you 3.